What is going on, everybody? How are we doing? So we're going to cover vaccines. This is going to be a short tutorial on vaccines and vaccinations. Go ahead and take a look at that. So vaccines, what they are, how they work. Let's go ahead and take a look. When we have immunity that builds up, all right, is going to build up because of the attacking of those different pathogens with our own immune cells. So, for instance, if we get some sort of viral or bacterial illness, the body is going to neutralize that. It's going to build up an adaptive immune response. This is usually going to require antibodies, especially B cell humoral immunity. A vaccine is going to be a synthetic version of this. Synthetic meaning that it's going to be artificial. So what we are seeing is getting a less than viable or less than lively version of a bacteria or a virus, having that injected into us. And then we are going to artificially create antibodies and cell-mediated immunity against this, okay? So we're having exposure to a modified version of a bacteria or virus that's going to allow us to prepare an immune response to it so that when we come across it in real life or in the environment, we have certain defenses built up already. So vaccination versus immunization, all right, two different terminologies. Vaccination is the physical administration of a vaccine. Vaccination is simply giving an inert virus or an inert bacteria, and then immunization is the process by which our body actually becomes immune. Immunity can be the result of having the actual illness, so not having a vaccine, but actually just coming into contact with that in the environment, contracting whatever the sickness was, the pathogen, forming our own adaptive immune response to it, okay? No vaccine is going to be 100% effective, so there's significant variability in the efficacy rates for a lot of different reasons. We can have immunity that is built over time. Immunity can also wane, right? So if we become immune to a particular substance, over time we might diminish that population of immune cells, or we might lose the efficacy of those immune cells and become more vulnerable to reinfection over time. This is the concept behind booster shots. So when we have booster shots that are given over the course of several months or years, this might be a mitigating factor in losing that immunity, okay? So this could be necessary to keep a long-term protection that is able to be maintained for the majority of the lifespan. So around vaccinations, of course, we do have a good amount of controversy that exists. Most vaccines are relatively safe. They have to undergo many years of testing beforehand before they're administered to the population as a whole. So individual batches are going to be tested for safety and efficacy in various procedures and various facilities all around. So individually, subjectively, of course, there is always the risk of variation. Everybody's different. Everyone's immune system reacts differently. So there are the chances of allergic reactions to particular vaccines in select individuals. That being said, there are 4 types of vaccines. First of all, we are going to start out with inactivated vaccines. Inactivated vaccines are going to be ones that are administering whatever the pathogen is, but it has already been killed before it is administered, okay? So they offer less immunity than vaccines that are made with weakened viruses or bacteria because they are still living. However, here an inactivated vaccine is one that has been killed. So we have the markers on the surface of that cell that we can see and we could administer, but we don't have the living variation of it. So we don't have the body's exposure to the living organism. So this may provide a diminished immune response, all right? Some examples of this: vaccines for influenza, polio, pertussis, rabies, hepatitis A are all inactivated vaccines. Second type are live attenuated. This means that they are living, but they have been attenuated or weakened. Okay, so these are the weakened versions of the bacteria or virus. Um, they're going to be stronger than inactivated types, and they're also going to be more long lasting, right? Usually 1 or 2 doses of this is good enough to mount some sort of immune response. Our examples of this are smallpox, chickenpox, MMR, which is measles, mumps, and rubella. Our third type is going to be recombinant or conjugate vaccines. These are where we have a specific part of a germ genome, we have a specific section of a pathogen that we take and transplant it into the body. Okay, so the vaccines are taking a specific part of a germ, i.e., its antigen or whatever, or is recognized on the surface of that cell to evoke an immune response. Right. Usually, we're going to have the same part of the body's immune system that is going to look to attack it. Right. Booster shots of this are usually not particularly necessary, but might be required. So these vaccines are going to offer a very high level of protection because we are getting pretty much a living sample of whatever this pathogen is, and we're getting a direct antigen or a direct indicator or marker of what we will actually attack if there was some real infection that goes on. So some examples of this, we have vaccines for pneumonia, meningitis, Hep B, and shingles. These are all particular recombinant conjugate vaccines. Our last one is a toxoid vaccine. Toxoid vaccines are going to approach the immune system from a toxic response. All right. So these are actually taking the secreted toxins that a pathogen makes and implanting them into the body. So we're taking specific secreted products from a cell, moving them into the body in the version of a vaccine. So we're not actually administering the actual pathogen, but we are giving some of the secreted products that that pathogen gives off and creating an immune response to those. So for example, we have diphtheria, also tetanus. These are going to be examples of a toxoid vaccine. Again, booster shots may be required, but booster shots are potentially effective or potentially required for all types of vaccines that we do get. All right. Some important vaccines that we see in childhood. All right. We see a lot of vaccinations that come in childhood. We have a set or a regimen of vaccines that we get in early childhood. Some of the most important ones that we see: MMR, measles, mumps, rubella, polio, diphtheria, tetanus, pertussis, which is also known as whooping cough, Hep A, rotavirus, chickenpox, and also meningitis, bacterial and viral meningitis. All right, thank you all. That was a tutorial on vaccines. Please like and subscribe to the channel, Twisted Science, also the Patreon, patreon.com/twistedscience for more videos. I will see you next time. Peace out.